So I'd like to highlight Devon Energy here in our jackfish operations in Alberta. In 2001, we announced our intent to eliminate freshwater use at our jackfish operations. At that point, it was a pretty radical notion. However, when jackfish commenced production in 2007, we became the first oil sands operator to use 100% saline water for our steam-assisted gravity drainage operations. So currently today, jackfish circulates over 20,000 cubic meters of saline water each day, and we recycle or reuse 95% of that. And we're also going to be using this same saline water aquifer source essentially in our jackfish 2 and 3 operations. Now, earlier I mentioned wastewater. It's this thinking outside of the box and truly taking a full toolbox approach to where are you going to get your water from. And I think EXCO exemplifies this with what they did in the Haynesville. EXCO looked outside of the box and said, look, we have a perfectly good, we understand what's in this waste stream, and it's coming off of the International Paper Company's Mansfield Mill near the Haynesville Shell. So they went and executed a 12-year agreement with this mill, and ultimately they were able to use this process water, which would replace up to 100 million barrels of conventional water resources with treated, discharged, quality processed water. And this water source is sufficient to provide for the drilling and stimulation of over 700 new natural gas wells. I mean, this is just a great opportunity, and EXCO did a wonderful job in evaluating and identifying that source. Another operator who's done a similar thing here is Seneca Resources right here in the Marcellus. We have acid mine drainage, and they've been able to go up there and minimize their freshwater use through the use of this permitted acid mine drainage withdrawal. Now, I believe Range, I believe Anadarko, and some other operators are using this AMD in the Marcellus. However, I will acknowledge that there are some remaining concerns around using AMD, and those include the long-term liability. I mean, if operators begin to use this, are we ultimately going to get hit with some kind of long-term liability with the use of this AMD? What happens when flowback mixes with AMD? Are there ample volumes with respect to quality to fulfill HF needs? And then also considering, again, I mentioned those logistical concerns. We're going to get into trucking. You have to have the ability to move this water. The water's got to be where your drilling and development is. So you got to put all these pieces together. But nonetheless, these are the type of thinking outside the box approaches that all operators need to be considering and contemplating when we go into new areas to minimize this freshwater usage. So for fluid handling and storage considerations, fluids handled for HF operations must be transported, as I mentioned, from that initial source of acquisition all the way to the use and following to the disposal. This is quite a costly ordeal. So generally these fluids are stored on site in tanks or lined impoundments. And if line impoundments are used, they must be constructed in accordance with applicable state and federal requirements. And these permitting requirements, generally we must review the site topography, geology, and hydrogeology. But one thing I wanted to note is, and I've kind of touched on this, is many operators are building line centralized impoundments, larger scale impoundments, to enhance the efficiency of their flowback water management process. And these are larger in size. They're able to bring large volumes and put them in a centralized facility so that they can continue to reuse this flowback water or recycled water throughout their operations, again minimizing that freshwater use demand. But these should be placed an appropriate distance away from surface waters, or at least have sufficient freeboard to account for any type of overflow. And operators should always implement an inspection and maintenance program of these. Now, an operator I'd really, again, like to highlight, I think they've just done an absolutely wonderful job in the Piceance Basin, is Williams. Williams not only implements these centralized impoundments, but what's even more impressive about Williams is they implement centralized hydraulic fracturing jobs in which they can do remote simultaneous operations for fracturing. And so this involves placing the fracturing equipment in a central location from which the equipment can pump fracturing fluids to wells on multiple paths. The equipment on one location is fractured up to as many as 140 wells, and this reduces surface disturbance, minimizes freshwater use, and reduces truck traffic all at once. I mean, this is putting it all together in the Piceance. Now, for transportation considerations, distributing water via surface lines. Water supply and management approaches should consider the requirements and constraints associated with fluid transport. Again, trucking costs. These are substantial costs. I mean, I think we'll get into deep well injection and UIC here in a little bit, but as we know in the Marcellus, your injection capacity is limited. Operators may face paying up to $10 to $15 a barrel to take this water from here to Ohio. So these trucking costs can be a major expense and can present issues, especially if you're looking at a Fort Worth development in an area such as the Barnett Shell. But I'm going to touch on trucking plans here in a second. But to minimize the cost and limit additional surface impacts while increasing efficiency, operators are often turning to temporary surface pipelines to transfer fresh water. In some instances, they're also looking at this to transfer flowback and produce fluids. However, you have to weigh the regulatory considerations there. So again, in some areas this may not be practical, especially with the flowback fluids due to cost effective or feasibility due to regulatory constraints. And I also just want to touch on the use of multi-well pads. I know Rebecca's probably going to get more into this in HF-3, but this increases our water efficiency while also minimizing truck traffic. And again, I hope I'm not stealing too much of Rebecca's speech here in HF-3, but I wanted to touch on Anadarko just for what they've done, and they've been recognized by the IOGCC in their Chairman's Stewardship Environmental Award for 2010 as implementing the Anadarko completion transport system in the Uinta Basin. And this is a highly efficient method of moving large volumes of water without trucking. And here they are able to move both freshwater and flowback fluids, and they're able to network them in a series of these centralized impoundments and efficiently move them so that they can meet the demand of their drilling operations within the Uinta. This also reduces truck traffic by 85%. It eliminated 1.5 million truck miles and decreases their freshwater consumption for well stimulations by 2.5 million barrels during 2010. So this is a wonderful, wonderful, again, piece of showing how operators are implementing this guidance day by day. So again, I mentioned trucking. I mentioned the cost. I don't know if we've really gotten into the nuisance factor. I mean, how much of the nuisance or issues around hydraulic fracturing is truly downhole with impacts to water wells, or is it really the public's concern about being stopped by trucks? They're having all these trucks. Even Senator Dorgan mentioned in remote areas of North Dakota, they're now seeing truck traffic. So when HF fluids are transported by truck, operators should develop a basin-wide trucking plan that includes the estimated amount of trucking required, the hours of operations, the appropriate off-road parking and staging areas. That's very important, and I think that we are continuously looking at this and saying, yeah, we need to develop this on a basin-wide approach and really think through this to appeal to the public. Common routes. Additional considerations should include, this is a key right here, seeking public input about route selection. And again, I'm going to mention coordination with local emergency management agencies, but also coordinating with these city planners. If you work with them, if you can work a deal and say maybe there's a different route out here, one we could work on together, that way we could minimize our impact on the local road system. We should also consider upgrades and improvement to frequently traveled roads and advance public notice of necessary detours or lane closures. So for kind of changing gears here, we're going to talk about water management and disposal now. Water use in the HF process is generally disposed of in one of 3 ways. There's also, I guess I should throw in a 4th one, would be evaporation in arid regions of the West. But it's generally injected in permanent disposal wells under a UIC Class 2 program. It may be delivered to water treatment facilities depending on region and permitting conditions, or as we've mentioned, it can be reused or recycled. Disposal options are dependent upon a variety of factors, including the availability of suitable injection zones. I mean, that's a very large driving factor right there. As we all know, in the Marcellus, they lack some of these suitable injection zones. So then these operators must contemplate, do we want to spend the money to ship it to an area that does have a suitable injection zone? Or can we find a way to reuse and recycle? And it's that innovation, it's that what I pointed out with Range and Chesapeake and these other operators that are finding ways to reuse these fluids. You have to understand your source water supply volumes. If you don't have an ample or adequate amount of source water, you're probably not going to be going downhole and injecting all of the water that you just flowed back. You're going to be looking at opportunities to recycle, and that's why I didn't want to diminish or downgrade the importance of recycling. And then flowback water quantity and quality characteristics. Again, if you have high quantity and high quality, that's wonderful. You have a supply source right there. However, if you have high quantity and very poor quality, it becomes a waste stream that you're going to have to assess and work in your economics. You also have to take into account regulatory considerations and resource economics. So as I mentioned, Class 2 UIC, deep well injection. This method of disposal is probably the most common method employed by E&P operators. Disposal by injection is widely recognized as being environmentally sound, cost-effective, and it's a well-regulated and established practice. In many areas, such as the Barnett Shell or areas of Texas, there's a vast number of injection wells. Operators have been utilizing these for decades upon decades. It's a safe practice. And it may be the most environmentally sound practice in some regards if you do have a very poor water quality stream and you consider an energy-water nexus and what it may take to recycle the fluids. This may be your best alternative, is just to go with an injection well. Another one I want to touch on is municipal wastewater treatment facilities. And this one I struggle with, because although it's often publicized and currently a topic of EPA's HF study consideration, we also see it show up in the SEAB reports and all these other reports. The discharge to POTWs is highly geographically limited. I mean, it's occurring here in Pennsylvania, and it's a very limited instance. However, it's been misconstrued potentially that this is a key practice of disposal that's used throughout the U.S. Well, that's not true at all. It's generally only here in Pennsylvania. There are very few operators that are now using this method, and it's highly regulated. A growing trend is the use of industrial waste treatment facilities. This allows operators or a private company to come together, pool their resources, and develop a centralized treatment facility in which operators can come in and bring their flowback water, and ultimately it can be recycled and reused, and this helps sometimes on the cost per barrel basis when you have this industrial centralized facility. They also can alleviate the trucking of waste streams within an area. Other disposal opportunities, this one is very important. Flowback and produced fluids are often used to replace fresh water sources for enhanced oil recovery operations or water flood. That makes up a lot of our water use, and that's a great alternative for your produced fluids, is to make that up with the EOR operations. So for recycling and reuse, operators should consider options for the recycling of fracturing treatment flowback fluid, and these options again will depend on the rates and total water volumes to be treated. If you have these high volume and very poor water quality, often your best alternative may be to use injection wells. And I don't see or foresee any problem in doing that, especially if we can tap into these non-potable water sources and we're not using fresh water to begin with. You have to account for the water constituents and their concentrations to understand what we need to do when we're recycling. Again, our service companies have developed additives, and a lot of these are even green additives that help us overcome these historical TDS concerns, total dissolved solids. But now we must take into account some other issues such as sulfates or iron scales, depending on what formation you're in. We also have to evaluate water reuse and discharge requirements. Water supply availability, again, I touched on that earlier, but if you don't have an adequate source of supply, then it is going to help your resource economics to be looking into how you can either dilute, recycle, or reuse these volumes. Now, our recycling options available in unconventional formations generally are reverse osmosis, and this works great in areas with low TDS. However, historically it's had some limited efficiency or feasibility in high TDS locations. You have thermal distillation. The limit here with thermal distillation, it's very energy intensive unless you have some form of waste heat that you can use. There's also electrocoagulation, which I didn't put here, and then you have pre-treatment, just very simplified forms of doing filtration or some pre-treatment and dilution, as I mentioned what a lot of the operators here in the Marcellus are doing. One of the last year operators I'd like to highlight is Incana. They've used an extensive water treatment distribution system to support their drilling operations in the Piceance Basin. The treatment facilities in the basin are designed to treat about 45,000 barrels of produced water a day, and they continue to develop more pipeline infrastructure and centralized impoundments, again, to move this water efficiently around the field. Once recovered, this water is run through a dissolved air flotation unit and for treatment before being placed into source water storage ponds. And they also have accounted for air emissions and risk to wildlife. They have certain storage ponds that may be covered. Last but not least, again, I'd like to feature Devon and what we've done since 2005 in the Barnett Shell. You'll see here, if I can get this laser pointer working. Right there we have a centralized impoundment. We've set up, I think it may be a little bit closer here. These are our fountain quell nomad units. They use mechanical vapor recovery in addition to thermal distillation. And ultimately we centralize these near our centralized hydraulic fracturing jobs. And some of our results we've seen, we've been able to recycle up to 22,500 barrels per day at our peak. We've processed nearly 14 million barrels of fluids with a recovery rate of about 11 million barrels of distilled water. And we've been able to frack over 100 plus wells with this recycled water. Now last but not least for my presentation today, and I know it was just brought up, HF-2 touches on baseline water quality sampling. And I guess the key message I would like to relay there is that baseline water quality sampling is probably not effective if you go back into a basin in which you've already been developing. That truly would not be baseline. But I think operators are voluntarily and proactively doing this, whether it's required or not, in these new venture areas. And so I think the idea here is upon initial development, planning, and resource extraction, operators should review the available water quality characteristics in the area. And if you deem necessary, or if you think it's prudent, to go and proactively work with state and local regulators to assess these baseline characteristics. Now this type of activity may be best handled by a regional industry association, joint industry project, or compact. One notable group here that's recently made some headlines that has voluntarily worked to develop a baseline water quality sampling draft plan is the Colorado Oil and Gas Association. So they're currently working through that. They proactively did that on a voluntary basis. Other groups that have looked into this idea and probably would be instrumental in carrying something out like this would be potentially someone like the Barnett Shell Energy Education Council or the Marcellus Shell Coalition. But there's so many variables and factors when you look at baseline water quality sampling. I guess I'm going to continue to discuss this since the question was raised, is that you have to identify first, does the area contain biogenic or thermogenic methane? And if it does, do you want to protect that liability if you foresee that that methane is showing up previous to your operations in the area? From there, you ultimately have to determine at what radius am I going to move out from my wellhead, and what are my sampling points going to be? Am I going to sample surface waters, or am I going to sample private water wells only, or am I going to sample everything? You next have to think about, what am I going to be sampling for? What are the constituents? These can get costly and this list can grow, so you really have to take that into account. And then the timing. Obviously you want to do it probably pre-entry, but then the big discussion I think is, are you going to do it post-HF? And then are you going to continue to come back, and how will that process work? You also have to account for, as we move that radius out, when do you begin overlapping with other operators, and how do you manage that? So there's so many pieces and moving parts with baseline water quality sampling, but I know operators here in the Marcellus are doing a good job with it. I know in many other new areas operators are proactively going in and assessing those areas. So I appreciate your time today. Thank you very much.